at this point, what I want to do is I want to check what my current sum is. Yes. I'll check what my current sum is. Current sum. Let's calculate my current prefix. No, my current Sawari sum. My current Sawari sum would be prefix of int minus prefix of. Okay, let's say it is prefix of int and prefix of start minus 1. So this should be my current Sawari sum, but start minus 1 if this is 0, if start is 0, this whole thing, prefix of start minus 1 should be 0. So I want to, before subtracting here, yeah, I'll just subtract if start is greater than 0 here. So this would be my prefix sum, my current Sawari sum. So if so I will maximize if this sum is less than or is equal to k, I should maximize, right? So max. This one, this should be the lingus. And now I want to decide which pointer to move. So the decision would be if current sum is greater than k, but so let me think. Let's say we're at some point, and if the next minimum I have, if current sum is greater than k, but the next minimum is will make my Sawari sum less than k, I should go to the right.
Okay.
So if current sum less than or is equal to k, or if this is the case, I should just go to the right and find out if yeah, I think if this is the case, or if next min of int, if current sum. So I'll calculate the next possible. If I move forward, I'll calculate the next possible Sawari sum. Next Sawari sum. This is no way. So at this point, what I wanted to try is, let's assume the current Sawari sum is greater than k. So I want to make sure if there is a Sawari, if there is a minimum after me, that will make the Sawari below k. So the next min is stored at this point. So prefix of that, prefix of that minus prefix of start, right?
Yeah.
But yeah, again, I have to do like this thing.
Yeah.
I have to check this thing. So maybe let's separate it out here. Next sum should be this, and so minus equal. Not start, but start minus 1 and greater than 0, or else 0. So if next sub, if next sub is less than or is equal to k, I should move to the right, right?
Yeah.
So this condition would be suffice, because if there is no minimum after me, myself would be the minimum in the next mean array. So
Yes. Mhm.
I shouldn't, maybe I don't think this would matter, like this part.
Mhm.
Uh, so here I'll just, if this is the case, I'll just move my end pointer. End pointer would be the next minimum index of int. Otherwise start would go with the increment by 1. Start would be incremented by 1. But if I'm at the end of the array, the next mean, so the next mean for the int should be greater than the index of the int, because assume if I'm at the end of the array, when I try to calculate the next mean, it will be valid. So if it is less than k, I will assign int to itself. So we'll be in an infinite loop. So I can just say here, this would be like the next mean of the int would be n of nums, or just I can initialize them. Nope. Okay. Okay. So like I need this part to calculate this part, but at the end I can make, when I try to do this, the last element, I can make it length of none. So here, return my max lengths. I wanted to go over to taste it with example, but I don't think I have much time left. Let's check.
Yeah, yeah,
Let's
we are
roughly
in the
check.
last 5 minutes.
Yeah.
In the last 5 minutes of the interview, so I think testing it with the given example, running it, not walks through, but just test run would be a good idea.
Oh, okay.
Uh,
Okay. So for the first 1 minute, let's just check the code if if
okay.
it doesn't have errors or something. So here, I hope this build the prefix array, started from 1 and checked if prefix of get 1. So this will build the prefix array, and we try to initialize the next mean array with -1, and we set the last one to itself and calculated the next minimum for each index. So the way we did it is we checked the current sum at this point. No. Okay, maybe let's check this part. Yeah, if the current prefix sum is less than, like the prefix sum at this point is less than the prefix sum at the next point in the next mean array. So the next minimum for the current element should be I. So otherwise, it should be the next one. Okay. I hope this is okay. And at the end, the reason I did, maybe this also might cause, this also might cause a problem. Okay, let me check one time. The reason I did this is to avoid the infinite loop problem we discussed. Okay, so we try to go until the int in the current sum. We try to
Do you
calculate the
think
current
that's
sum.
enough condition?
Sorry?
Do you think int less than length of nums is enough condition, or do you have to consider other?
Okay, if that is the case, is there a scenario where start and end cross each other? If that is
Think about that.
Okay, if there is a scenario that would happen, I think I should also check for that case as well. Okay, so what if one number? Yeah, that's right. What if one number by itself is greater than k?
All of them, if all of them are greater than k,
Mm.
you won't have a sub-array less than k. So
Yeah.
I think start will surpass int by then.
Yes. So here, while start, so I think we might need this as well, but I'm not sure if this condition will cause an early termination to our algorithm. Okay, maybe let's just test it because we are out of time.
Yeah. Okay.
So I would love
Let's
to.
start.
Sorry.
Let's start with the example you have been working with.
Okay. Case 3.
Wait a second.
Okay, name is not defined. There is an error. Yeah, there's a bug in our code.
Okay.
So yeah, if the problem is with the next mean, if the
Yes.
current if next so I don't have to do this one. I just need to check if the next when I try to calculate. So if here I also need to make sure int is different from next mean of int. And it gave us a wrong answer. Okay.
So, what do you think will happen? Do you think we should consider also tracking the longest? If it's less than or equal to k, like the next mean is certain index, and we know the sum from start the next mean is also less than or equal to k.
Yeah.
Do you think we have to consider max lengths?
Sorry. So
Do we,
maybe. Carry
do
on,
we
please.
have to conditionally update max lengths if next sub is less than or equal to k? In this case, the thing is it terminated early because it appears in the last, in the last subarray. So is this the only case that we are updating the max lengths, or do we have to
Okay,
consider other
so
scenarios?
my idea was if this is true, when this while loop goes to the next iteration, the current sum would be equal to next sub, and I'm going to update it at this point. But as you
What if it
might,
terminates?
and I'm trying to think of a condition where it terminates. So maybe to be sure, we can also do it here. But like, I want to know at what condition it terminates. Okay, this would be next min of int. Okay, let me check. Still that's not the case, I think.
Can you wrap up in like 2 or
Okay.
3 minutes?
Okay. Maybe this tab closed it. Well, no. So I couldn't figure out why this is happening, honestly. Okay.
So I
Okay.
think
Let's. Yeah.
that's
Yeah.
the interview.
Yeah.
Thank you very much, Ben. You tried your best. Um, Guys, this is not an easy question. I think this is one of the toughest problems that might encounter in your maybe whole career job search job search process. Maybe because this involves three tricks. It's not as easy as the question might seem. It includes prefix sums, it includes two pointers, it includes monotonicity, and our candidates are the best candidates in A2SV, and they have tried their best. They have tried to work out to the optimal solution. Mahi has implemented a brute force approach. She also tried in login solution, but sadly it failed because of some issues in her approach. Yeah, I think this was overall it was a very good interview. This is, I mean, I would expect this question to challenge anybody, including anyone in ATSV would be challenged by this question. So please thank Beimnet for his time to attend this interview. And guys, I really would love to hear from you after Beimnet and Mahi are dropped out of this conversation. I would love to hear your true comments about their performance, because I may not be able to judge optimally. Like what I haven't seen, you might have seen something, and that could be a good point for one of the candidates, and I might have missed that. So I really wish if you, I really would want to get some feedbacks from. I think we don't have Beimnet, and there is we don't have Mahlet too. So please speak up. Guys, I know Nati. Any feedback, guys? If there is no feedback from you guys, I think I have some parameters that I have been keeping track of when we started the interview. One of them is asking clarifying questions. I have 5 different parameters. Each of them have 5 points: clarification question, problem understanding, approach and walkthrough, the speed used or the speed someone used to implement the solution, and the optimality of the solution. In the clarification section, I think both of them did good clarification questions. Mahi asked if what is the smallest amount of Sabari links I might return, and then he also asked, even if it's obvious, he asked that there might be, he noticed that there might be negative numbers, so he was aware of that. And in the understanding section, understanding of the problem, Mahi, I'm sorry if it was from my end, but Mahi didn't understand the question well at the start. So she ended up taking maybe tens of minutes solving a question that she hasn't understood well. She thought she was expecting an exact K difference or exact K sum in the Sabari, but the question was less than or equal to K. And I believe I have stated that in the statement, but she didn't catch it. That might be a problem, but Bemni understood the question quickly. And next is their approach. Both of them come up with the need for prefix sums. Both of them also come up with the need for 2 pointers. Mahi suggested sorting the prefix sums, including keeping track of the indices, so that you would know what the length of the Sabari would be when the condition is satisfied. But her solution failed. Failed short because of the 2-pointer approach. I wasn't even also able to help her because she was a little behind the right direction. In the case of Beimnet, yeah, he started with the brute force solution. It was n cubed, and he improved it to n square. N square, he thought of multiple solutions. N cubed initially, and then n square with prefix sums, and he thought he can do it or n with some extra space and pre-processing. His approach, when he approached the problem, he tried looking for simpler versions of the problem, which is very important. I think it helped him to come up with an approach for the optimal one, even if he fell short in implementing because of time, which I think is inevitable in this kind of hard problems. So I think since I have also given Ben some help, he was like nearer to the optimal solution. So he kind of like I believed he needed some help, so I gave him some hints, and I deducted 1 point for that in the approach. For Mahi, I think we were out of time, 10 minutes. We were only left with 10 minutes, so I advised her to start implementing the brute force solution, and she managed to implement it. And she also has got 4 points here out of 5. Both of them have scored 4. Speed-wise, I think Mahlet's interview was on time. She finished in the time window of 45 minutes, but Beimnet ran a bit out of time, like 5 minutes, and that's why I'm giving Mahlet a speed of 3 and Beimnet a speed of 2. Sorry, a speed of 3, because he was trying the optimal solution. Optimality of the solution. Mahi's approach was to come up with n log n solution, but that didn't work, and I'm sorry she didn't get any point for the optimality of the solution. But when it comes to Beimnet, he has almost completed the the problem. These are just the algorithm. If it's set correctly, the algorithm would work. Keeping track of the next minimum would help us to see in next to me, can I find some negative numbers that would reduce. And I gave him 3 points here. It might be it might be debatable, but I believe he deserves it. I gave him optimality of the solution 3 out of 5. And now we can add them up. 3, 2, 5, 9, 9, 3. Mahlet got 12 out of 25, and then 7, 11, 14, 14, and 2. 16 out of 25. Based on my matrix, Mahi scored 12 out of 25, and Beimnet scored 16 out of 25. So based on the notes that I have been taking, this is my detailed feedback on this interview. Thank you guys so much. If you have anything to discuss, please brought it up. I may not be judging ultimately. Okay, in that case, we will be wrapping up the last game of the ACL semifinals, which were held between Beimnet and Mahi. Thanks everyone for attending. I hope you enjoyed this session, and you'll also enjoy the next, which is the final between Nathaniel Murgita and Beimnet, which hopefully is going to be an amazing game. See you then. Bye bye.